Go.
We gotta wait for the attendees to come in. Here they come. All right. Good afternoon, and thank you for joining this month's edition of Alpine's webinar series. This month, we're going to discuss Charlotte's Web, network design, and how to meet your service level agreements. We speak in acronyms, so SLAs, service level agreements. For those of you on the attendees, please feel free to use the chat or the Q&A at the bottom. We have muted everybody, and we will open up for a Q&A at the end. But before we begin, let's go to the legal disclosure. Steve, if you go to the next slide for me. So the information discussed in this session represents the views of individuals and does not constitute legal advice. You should consult with your organization's leadership and legal counsel. So if you go to the next slide. For those of you that don't know me, my name is Michael Wolin. I'm your moderator today. We're going to talk with our leading distribution network analysis resource, Steve Silva. Steve will actually be going through our event today. As we begin, we're just going to create a poll. What prompted you to join this webinar today? Interested subject, want to learn more? Process of doing a network analysis, planning to do a network analysis in 3 months to a year, or need to understand our options with regards to sourcing and transportation costs as they continue to grow. So believe it or not, we're doing strategy sessions right now, and a lot of our customers are either doing a China +1 strategy, switching to nearshore, or looking at different service level agreements with e-commerce. So it's really driving that. So fantastic. All right, if you go to the next slide for us, Steve, we are going to go ahead and talk about how we're going to get this going. I think you went the wrong way, buddy. Wrong way, Steve.
Yeah, I'm working on that. I'm hitting the down button. There we go. All right, a couple of good looking mugs, and then we're at the agenda, huh?
Yeah, so we're going to take a look at the Alpine network experience. We're going to discuss decision support systems. And I was told there'd be no math. We're going to go through the perfect number. No, it's not infinity, but we will go through the perfect number. We'll look at the tools to convert data into information. And then we've got 3 samples today. A specialty apparel company, a manufacturing company, and a daily delivery company. And then we'll open up for questions at the end. So without further ado, I'll turn it over to Steve Silvis. Steve?
Yeah, well, thank you, Michael. You know, it's always fun, and if you like the math and you like the modeling, it can be intriguing. And of course, the environment is just expanding, and you know the work at home stuff, and it's just going nuts. It's really exciting. And of course, if you're a math or if you've got some type of knack for math, sorry, but some of us get excited. So here I am. You know, we're going to talk about a couple of examples I'm going to get to. And if you look in this chart as well, I'm just posting a few across different sectors that we have worked in across our careers here at government, with the Department of Defense, the U.S. General Service Administration, Marines, some waste management, chemical and ethanol. Then there's the manufacturing, always strong in the manufacturing, of course, in the Midwest. Retail, that's always, you know, the big box stuff, and that's always, of course, growing. And then some distributors, some special distributors, bikes, industrial supplies, and school supplies, and so forth. Just a whole host. And I always say to people, I model nouns and verbs. You give me the nouns and verbs, I model them, and really it can go across many sectors. So, you know, it's always calling for help, and you might have something in mind, and it's always thinking, you know, give me the optimal. And these are quotes that I quite often hear. Give me the optimal, you know, optimize my customer service. Where's my best locations? And there's oftentimes, I don't think that we really give a lot of thought to the actual quantitative objective and what it means. You know, just give me a location so that I never miss sales. Well, eventually you're going to miss a sale. That, you know, there isn't an infinite amount of inventory on hand to really cover everything. But first, I want to have a little tongue in cheek here. The perfect number. This has come up so many times, and it's actually quite fun because there is such a thing. The perfect number, and this is the Encyclopedia Britannica, is a positive integer that is equal to the sum of its proper divisors, smallest being 6, which is the sum of 1, 2, and 3. And there's other perfect numbers like 28 and 496 and so forth. So when you say the perfect number, If you really got the math geek on hand, that's what they're going to give you. Here's kind of a picture, a look at it, of how it looks. It really has no significance in math, even historically. It might have provoked a little different type of research, but it really is nothing more than a fun little thing that came up centuries ago. So let's get into what's real and what matters to us all. There we are. One thing, when you're looking at this modeling, you're looking at the network modeling that we do, what you're doing is what I call a decision support system. And there are components in that, and that's really relating data to information. Of course, there's such a plethora of data, and we can all go get it. And geez, we can make it up if it's not even there. There's so much available. And there's always what little adjustments from whatever other network or whatever. It's so rich. So, but it's important, I think, and I want to emphasize this before we get into it, the detail, is there's components that you need to really focus on. And then you can expand that with your vocabulary, but really you have to have a function, an objective function. Am I maximizing? Am I minimizing? What am I doing? There has to be something to have an objective function. And those can be loose as well, and they can change as you go through a particular analysis. So it's not that you have to have this thing anchored on, but you have to understand when you're doing the analytics, you're driving to a function that you should have an understanding for, based on decision variables and constraints. I want to meet all the sales I can with 3 locations domestically. Okay, and I want to meet it within 3 days. Well, now you have decision variables and constraints. You said 3 days. Well, then you might find out that 3 locations isn't enough. So now you have to expand that. Or you can say, let me loosen my constraint, which was 3 days, I'll make it 4 days. And then all of a sudden you have a play between decision variables and constraints. And that's quite commonly the case. And then when you're doing any of this modeling, one of the important things to ask is, what is the range of sensitivity? That is, I see the solution, but how well does it apply? If fuel, for instance, changes by 15%, what does that do to me? If the price of a container going overseas would double or triple, can you ever imagine that?
It's happening right now.
Yeah, I think that's about the last 6 months. So that is a type of sensitivity. If that happens, what's going on now? And what does that do to my results? And of course, it dramatically changes things in this case that I gave. So, I like to say in great fun that, really all models are wrong. It's really up to the art of the user and the modeler to, if you will, make them useful. So what's it take? Some very basic tools. I'm going to show you this slide. I'm going to show you this slide again, because as I go through the examples, I'm going to draw on some of this. But there are a lot of good tools in the marketplace. There are a lot of good tools that go by a single name, and people, often you want to have those tools, and they're good. And they're made by brilliant people. They're made to sell software and made to do general analysis. But when you get into your network, you're going to always say, well, what about, it's a little different. It's a little different for what I do. And of course, that's often the case. So what we've done at Alpine is we put together a tool set. And of course, that isn't all inclusive. That doesn't mean we have the answer to everything, but we've got a tool set that we know where to drive it, and we can take and really apply it to your situations. And so what do you need? You need industry aptitude. You do have to understand how data becomes information and becomes useful. There are a host of algorithms. They're public. They're in the academic journals, and they're programmable. And that we use them. We use a lot of them. There are particular ones are positioning, which is very common. We use something called assign and align, and through that repetition, you can come up with a very good position spot. Routing is another one. We use a very simple algorithm there called furthest first nearest neighbor, and that feeds into some of our tools as well. So, and now it's the art of understanding and applying that math. Also, you'll need rating engines. We have a parcel rating engine. Parcel is based on zones, which is developed by 3-digit zips, and then is discounted based on your specific discounts from your contracted carrier. LTL is usually a freight class and weight and service, and we have those rating engines as well. And then truckload can be a variety of things, but it is generally a price per mile with a stop, with additional stop. That price per mile can be dependent on state of origin and destination. For instance, getting into the state of California is very cheap because getting out has a high demand, and they want trailers there. They'll do, the cost to get in there is very cheap because the revenue of getting out is very profitable for the carriers. So then you got to have a database tool, and you want to have some relational database aptitude and some coding capabilities. And there's a host of programs that can do that. There's obviously a very good network of shared programs as well, and groups that can talk online and so forth. A lot of great tools there. Then a plotting tool, you always want to see how it looks on the map, don't you? So we have those as well. And then a zip code database, because that's one of the drivers of distances as well as costs relative to carriers.
So Steve,
yeah, Michael.
Yeah, I was just gonna say, so I mean, obviously we get the basic tools, right? We got the data, we got the math, we've got the engine, we got the tool, we got the plotting tool. In your 20+ years of doing this, what's the hardest one for an end consumer to get together to make this project successful? What's the biggest hurdle they overcome?
Probably building the relationship among the variables, because right, the rating engines you can buy them, and a zip code base you can buy, and tools you can buy it. The algorithms are pretty much there, but it's understanding how you build that relationship and how that actually drives it. Because when you start talking end to end, well, that's so convenient to say end to end supply chain. Well, wait a minute, does that mean the production sequence in China affects what I put on the floor? And how does that affect it? And absolutely it does. And now you got to start looking at all that and how it compiles up. So I would say probably the relational data aptitude.
Okay.
Thanks. So I'm going through some samples here. I have an apparel, a manufacturing distributor, and then I have another group that is focused on daily delivery. Apparel. And I'm going to talk about this first. It's a specialty apparel. So they have dedicated demand, which is quite interesting. Probably the first time I came across this, in that it's dedicated customers. So they can just about tell how much, they know how long it lasts. But yet the question is, where still do we put our facilities and how many? They have dedicated demand detail. They have monthly seasonal variance, fairly consistent. They have a cost of capital, which was huge in this particular analysis. And then they have ports of entry. Out of that, we're going to drive distribution centers, their locations, their serving demand, that is who they serve, which specific customers. And these dedicated demand is also a dedicated design. That apparel has to look in a particular way, and we know who it's going to. So that was kind of a challenge as well. And then the inventory positioning, specific SKUs and in quantity, and then safety stocks with confidence intervals. That wasn't as relevant, safety stock, because it was a fairly predictable demand, and but it was worthwhile looking at. And then this one, the growth opportunity was fairly relevant, and I'll show you that in the picture here. So here's the solution. And what we have is, I'm showing at the bottom, I'm showing the tool that drives all this, but here's the solution. It came up with a central Texas solution serving all of these hubs that you see on the right. The red are the little hubs. The blue are the demand points at the end. And we go through all this and we apply our tools. We have suppliers, we have inbound to DC. We capture the DC operations, the outbound to the branch operations, and returns, which was actually very relevant in this one. So we bring all that together, and then we have these strategies. And all I'm showing you here is the buttons that control the user interface for all that great math that we do. What I wanted to point out here was, when we did this, something struck us in our analysis, because we make comparisons and so forth. We say, what's going on? If you look at the red circle, what's going on in Ohio, Pennsylvania, New York, and so forth? That's the population density of the country, and you're not there. So if I tell you where to go based on what you have, that might not serve where you're trying to get or where you have growth opportunity. Turned out this particular customer still saw a great opportunity in Florida. And we're looking at some acquiring for that capacity that's missed in the circle. But I thought that was a relevant thing to point out, because we're driving an objective. The objective was current demand. And I'm looking at that as an analysis to say, wait a minute, look what you're missing. So, and that came into it as well. But again, that was something they're looking for down the road.
And Steve, I think that's another really good point, though, right? Is we're going to take either 2019, 2020, year to date, 2021 inbound data, outbound data, but who's to say somebody isn't going to change and do a procurement event for your sourcing resources? So all of a sudden now your source that you're getting the product from is coming from a different location. So to your point, the aha is, hey, just because we can go and do this about today, let's add the variables for tomorrow. What if we source differently, or what if we add a different market, or what if we make an acquisition and go into a new region? So it's one thing to do a snapshot with the data you have today, but to think about and apply different scenarios for the future. So
yeah, absolutely, Michael. And that's where we use what I call the sensitivity analysis. Okay, well, give me, what if I grew in these areas proportional to the population that I have in other areas? Now what would happen? So serves very well, thanks. Next one, domestic manufacturing. Here, there's take 2 pages of data and information. Assembly and relocation of sub-assemblies. They had domestic components that were going to, well, let me just move this. Yeah. They had sub-assemblies and they needed to maintain that with components. So we had component support, which involved trailer capacity, transportation costs, demand by both within domestic regions of the product detail. We had product detail, target growth. This one, I think we set out about a 3-year growth plan. And there was aftermarket parts that was combined with this, with the assembly as well. And as you might know of recent, there are some labor availability challenges. So that certainly came into play as well.
No way. That's happening everywhere, Steve?
Yeah, just imagine that. So, and then taking that data, we want information. So we want to know, what is the component flow to foreign assembly? What are the finished good inbound? The inbound flow back? What's the trailer utilization? When this particular one, I remember looking at it when you pack a container overseas, you generally do very well at packing it because it's going to be on the move for 4 to 5 weeks. So people are very focused on it. There's no question about it. I remember working at Philip Morris on their outbound containers, and they would just be packed. I mean, you couldn't get another cigarette in that container. I don't know that people give that all the focus and respect that they should domestically. And for this particular client, we really drove that. It was in Mexico. We said, yeah, that trailer is still going. Let's work on the utilization. And that was something certainly that we pointed out in how better to do that. And there's certainly a host of software that can do that for you as well. So then there was a finished good distribution product coming back into the country, did not need to go to the historical locations. There's mixing the SKUs. We have worked on facility sizing and staffing. Then the outbound, we had trailers, multi-stop trailer routing. And there was partner distributors in this particular one, some which were used more than others, but it was brought up if you will, another ARC node in the old model. And then aftermarket parts from 2 divisions, the locations, the buffers, the service regions, days of service, and then the expedite capabilities. Some of this product is got to have it overnight, and not all of it could be served by ground. There we go. Or did I go too far? No. And here's a look at the user interface. The focus here was transportation, material handling, and weighted hours of service. And we just went through this. This is just a sample. We went through, on this case, over 50 what ifs. And each time you come up with a solution, you start asking, what would be the next? What if and what if? And the end result, yeah, here I'm saying, we had over 50 scenarios. I know people always like to say, give me three to get comfortable and look at. As soon as you see them, you want to start expanding. And we're set up very well at Alpine to do that. Whereas because we have the custom tooling that incorporates the algorithm and so forth brought from the industry. Here's a solution. The sites, scenario sites on the left, showing the demand locations. On the right, not only are we showing the distribution centers, but the day's service, where the green is 1, yellow is 2, and red is 3. Now, when you look at that, and I talked about a bit earlier about the expedite service, some of this product has got to have it next day, so it can be expedited as well. And that certainly gives a look for it as to really what the coverage is. Now, it's always the look, but of course, behind that is the data that supports it, which is really what drives the objective function. Here we are. Automotive Parts. They're our third sample. They have 100+ branches, and they wanted next day delivery. The information is historical sales and margin, and that's going to play in our the margin is going to play in our safety stock. They have vehicle registration by county. Information is how many vehicles are in a county. Also have record of frequency of failure. Of all the industries, automotive for decades has been so rich with data. And just capturing, I don't know if we've all used it or not, but it's just so rich. And they know how long a radiator is going to go, how long alternator is going to go, how soon the battery has to be changed, how the light bulb. I just did light bulbs on my car. When you know it, 2 of them went out within a month. Well, that's all known, and that type of information is really relevant. That type of data is relevant in trying to build the information. What we got out of what we're trying for was the inventory positioning, specific SKUs and quantity. Batteries in the northern cars are a little bit different than they are in the southern, and so forth. And that's back to that vehicle registration. You know exactly what vehicle and where. Then the safety stock. That was based on conference rules, and that got some into the heavy mail, where you didn't want to necessarily have a 98% confidence interval for everything. Some things the margin was too low, or for that matter, sometimes a neighboring branch could serve it as well, and that's where we got into pooled branches. So a branch could take fewer items of the slow movers with lower margin, have a lower safety stock based on confidence intervals, and then they could have a branch nearby cover when necessary. That became quite, if you will, a challenge for that, and it was actually, I think it brought a lot of money, put a lot of money back in the bank. So here we are, 100+ branches, over 100,000+ SKUs, and all I'm showing you here again is a bit of the user interface that drives all this. And that's just a look at what's supporting the algorithms. And here's a look at that. In this one, if I go back, this is a user interface written in VBA with a SQL script. You're looking at an access interface. This then is the Excel output, which we all got to have, because then you can do your own summing and adding and dividing and so forth. And that's what we have here. This picture shows you the locations, the 100 locations nationwide, and the specific delivery points that they will make on a daily basis. This one actually had some good overlap, and that really got into safety stock. And if you see up here in the user interface, we have a tab specifically for the safety stock using standard calculation, standard deviations for a one-tailed distribution. So some good stuff there. Looked at this pooled inventories and combined across. So back to the tools. The aptitude is really what is the art of it. Michael had asked what do you really need? What's most important? And I referenced the relational data aptitude, being able to take these tools. And while this looks like a really nice, I'm gonna go back one. Well, this looks like a really nice user interface. The importance is that behind there, we can calculate a standard deviation, establish a safety stock, and the need for pooling inventory. And that's all in the heart of that. So it's data and information, the algorithms that we have and applying it. Again, the art form of math. We had the rating engines. And we had to even add here expediting carrier rates. I should be adding to the list. Airline rates. So the relational tool that I showed, the plotting that you saw as well, and all the locations are supported by zip codes. So I think that's about it on the detail I presented there. Michael,
yeah, so I was just going to say, for anybody that's online, feel free to use the Q&A or the chat to ask a question. So Steve, you went through one, and I know for me personally, the project that we did early in Alpine's career was we had the need to have 98% next day coverage. So we needed to determine exactly where the DCs would be based on their existing customers, because they were manufacturer and they needed to make sure their parts were there, because if their printing machines went down, right? So that's one type, right? Service level. And then this last one you did was about inventory and inventory placement, and then starting the pool. So in that one there, you're really going after the carrying costs and minimizing your safety stocks and inventory levels. But I think most people really look at it from a transportation cost perspective. And then they look at, what's the driver, right? So is it really transportation costs? Is it really service? And then what's the trade-off between those? What have you seen? Is it more transportation costs? Is it more service level, or is there a correlation between the two?
Certainly. It's hard to look at that when you're in a warehouse and you're packing it. You don't often get the reality that transportation is the cost. Moving the product is the cost. But of course, what you're also dealing with is the missed sale. And if the missed sale has a cumulative effect throughout the future, that's always a tough one as well. So, but yes, transportation, certainly that's always the cost. I think they say something like 80% of the distribution is transportation. But then it comes to that mode. And when you have a lower margin item, a very competitive item, you have to watch your cost. So you want to get that low cost mode and make it happen in transportation. If you have a higher margin, you have a manufacturer that has particular, we didn't serve Caterpillar, but they're one of the greatest at it, whereas a machine down anywhere in the world in a day, they got to get that up. And that's why you buy it, and they'll expedite it. So they'll compromise the mode to get that. But what really is the market is going towards, well, how can I actually get that confidence interval without expediting? And that's really the challenge. So when can I put it? And that was that one that I showed you here where I think it was only northern Wisconsin. Northern Wisconsin, a little bit in the Dakotas that had more than 2 days ground. So that really is focused on transportation, combining that with the cost to say, hey, it's nice to have it or to get it there, but we can't do it at all cost either. So.
Absolutely. And again, feel free to use the Q&A or the chat. I got one more question for you. What we're seeing right now is, okay, fine, we've done the distribution network analysis and we've figured out that the lowest cost is here and the best service level is there. But I don't think I've seen in my career the impact of the real estate cost and the impact of labor availability and cost have such a weight on a distribution network analysis. Any thoughts on that?
Oh, the labor is just huge, Michael. It's just right now, and I hear that all the time. I have people who come to me, hey, we'd like to increase our market share, but we don't even have people that can fill it, put it in the truck. We don't have people that can unload the truck. So, so I've had people that talk about network and say, well, sometime later, because right now, even if we grew, we couldn't serve it. As far as the real estate, I don't know. I haven't seen that driving yet. Certainly in the last 18 months, there's been a downturn on that and probably a little less demand, but I expect it will come up as well. Although the more the more you hire great analysts like the Alpine team, you can do it with less inventory and less real estate, and that's money in the bank. So
that is a good dream, but sometimes dream and reality come through, right? So on one of your slides, you said that modeling is never right, but it's better than being wrong. What did you mean by that?
Every model is wrong. Some are useful, and of course, that's what the math geeks do at the winter conference. We sit around and debate about who has the better models and all that. And of course, they're all debatable, and they're always, what I really put that for is to understand the sensitivity of it. That you have to understand what you're modeling and that sensitivity, because you can make assumptions and all of a sudden, well, hey, the truckload rate going into Kansas is anywhere from $1.95 to $2.15. Okay. But as soon as there's other demands or whatever else, what happens to that? And you have to understand that it can always be critical. You can always be critical of your model, but if you understand it, you have the art of using it effectively.
Very cool. All right, so let's say we go with the single tier approach. I just want to look at my inbound and my outbound transportation. How long does it take to build a model, and what's the duration of a project to model that?
Oh, a single tier, I guess what they're saying is they're not interested in looking at the supplier base coming in, but just the outbound.
No, I said inbound and outbound. So just inbound and outbound transportation.
Yeah, because, and there's the general answer to that, Michael, we generally do things fairly well in about 3 months. There's no, I can put that down pretty well because I'm without skirting the answer too far. Three is a good way, but of course, then there's always the ifs, right? Do you have clean data? One of the bigger things when it comes to clean data is, do you have a single source? If you have multiple sources, if you have a transportation management system and an ERP system and they aren't integrated, now that's work that we have to do and that bring it together. If you have your procurement different than that's different as well. One of the big things is, do you have a single source? And typically, if you do, you typically have a fairly good chance of having the driving information. So
So
that,
the longest pole in the tent is the data scrubbing, the cleansing, and then being able to set up all of your variables and your optimizations of it. But I appreciate that wholeheartedly. So, 12 weeks, 3 months. What happens if you add complexities, right? So now, not only do I want to know the inbound, outbound optimal locations, but then I want to add real estate costs, labor, and what my inventory position should be in each site. How does that extend the project duration?
yeah, that certainly can bring a challenge to it all. And I would note first, Michael, that's really one of the things as a model, as an analyst, that really is probably a sign of success, is we do the project, but we embed ourselves and our clients are saying, hey, wait a minute, you got more. Let's look at this. Let's look at the example that you gave. What can it take? Obviously, you can span a host. Some of those are just a weekly thing. I have one that came up and they wanted to do it in different phases. And then they learned that the first phase, the way they wanted to do it, was really going to put a ghost town in a warehouse. So we went back and had a minimum in the first phase. That took me a week. But the data was set up and the algorithms were there. So that can happen. But if you're all of a sudden going to say, wait, let's add a couple of different divisions, and we are a multi-division company, and we got to add some different divisions, and we've got different sources. They're not even in the same data management system. Then it gets to be more. It can be a month or so. But you do have, once you get things set up and you get the users educated and your clients understanding how you're going about it, that always accelerates if you will, the continuation.
So to that point, once you have all the data cleansed and scrubbed, you've got your optimization engines running and you're doing the modeling, what does it take to do the what ifs?
The nice thing there is, if you set it up in advance, you say, hey, look, we're going to do these what ifs. I'll change. One of the bigger things that drive it is capacity. Well, how about if we change and we serve this region here off a different facility because we're putting in an ERP at a new location? We just soon not have that. So quickly changing the volumes from one location, although the optimization might have said one location versus another, overriding that can be very efficient. If you set the what ifs come at you in a hurry.
All right.
If you get in, over the internet, I must say, people have asked about how is it met with COVID and what's that doing to it? Well, I think yet still the personal contact and the dialogue can still help catch a lot of things that go on, particularly when you ask about what ifs. Because as you hear those little intricacies sitting around a conference room, those still can be picked up.
I hear you. All right, David, what's the poll say? Can we get some poll results? And Steve, let's go to the next screen while we're pulling up the poll results. All right, so in process, planning to do. Okay, so we probably should have done the poll a little bit later when other people join. All right, fantastic. So if you guys are interested in learning more, schedule a best practice assessment with Alpine. And then Steve, for next month, what do we got up? Our good friend, Mr. Tom Ryan. Yeah. So Tom Ryan, the first Gartner analyst, will be speaking on the battle of the bots. So we actually did a very detailed research paper on all the different goods to person technology, AMRs, and robots. So if that's of interest to you, please join us on September 22nd. Until then, thank you for your time. Thanks for taking a little bit out of your break on behalf of the entire Alpine team. Thanks for joining this month's session of our webinar series. Have a great afternoon, everybody.
Yeah, thank you, Michael.
Thank you, Steve.